So far in Chapter 5, we've learned 5 formulas. We're going to learn 4 more formulas today, but those formulas are going to be based off 2 formulas that you already know. The first formula we're going to look at is the area of a circle. The area of a circle is going to be pi times the radius squared. And the second formula is the circumference of a circle. The circumference of a circle is a lot like the perimeter of a circle. It measures how far around, the length of the line around the circle. The circumference of a circle is found by taking 2 times pi times the radius. We're going to use those 2 formulas to develop 2 new formulas. And those 2 new formulas will have us measure arcs and sectors. A sector is a piece, a portion of a circle. It's like a piece of pizza or a piece of pie. It's a portion of an entire circle. So if I want to find the area of a sector, I need to base my area formula on the area of a circle formula. So the area of a sector is going to be based on this formula. So I'm going to use that in my formula. But I don't need the entire area. I need just a portion of the entire circle. And how do I figure out what portion? Well, I need to look at this central angle. A central angle is formed by 2 radii of a circle. So to figure out what portion of the circle I need, I'm going to take this central angle and I'm going to divide by 360 degrees. So if this central angle is 180, I have half a circle. And that makes sense that the area is going to be 180 degrees out of 360, half of the area of a full circle. If this angle is 45 degrees, I'm going to have a quarter, or excuse me, if this was 90 degrees, I would have a quarter circle. And that makes sense. I would have a quarter of the area. Now if I want to find the measurement of an arc is this piece right here. I'm going to label this point A and this point B. If I want to find the measure of arc AB, if I want to find the length of AB, I'm going to base it again off of this angle and the circumference formula. I'm going to start with that circumference formula, 2 times pi times r, but I don't need the entire circumference of the circle. I only need this portion. Well, how do I figure out this portion? Again, I'm going to use this angle, theta, out of 360 degrees. So I have 4 new formulas, but they're really just based on 2 formulas that you already know. To figure out the area of a sector, I'm going to take the area of a circle and just use a portion of it. That portion is determined by this angle. To figure out the length of an arc, I'm going to use the circumference formula, but again, I only need a portion of it. In example number 1, I want to find the measurement of arc XY and the area of this sector. Let's start with finding this arc length. I'm going to start with the formula for the measure of an arc length. Theta out of 360 degrees times 2 times pi times r. And I'm going to plug in the information that I know. Theta in this case is this angle right here. Well, I need to figure out this angle. From here to here is 250 degrees, which means from here to here has to be 110 degrees. In an entire circle, I have 360. If I've gone 250 degrees, I need another 110 to get to 360. So my theta in this case is 110 degrees times 2 times pi times r, which is 3/4 of an inch. Now I'm going to do this problem without touching a calculator. The first thing I want to do is reduce this fraction. 110 divided by 360, since they both, the numerator and the denominator, end in a 0, I can just cross off those zeros and reduce down to 11 out of 36 times 2 times pi times 3/4. Now my second step is I'm going to turn all of these numbers into fractions. So 2 becomes 2 over 1 and pi becomes pi over 1. Now any time that I have a number in the numerator and the denominator that can be simplified, I'm going to do that. So I can simplify this 2 and this 4. 2/4 simplifies down to 1/2. I can simplify this 3 and this 36. 3 divided by 3 is 1. 36 divided by 3 is 12. Now I can multiply my numerators all the way across. 11 times 1 times pi times 11, or excuse me, times 1 is 11 pi, all over 12 times 1 times 1 times 2 is 24. So the length of arc xy is going to be 11 pi divided by 24 inches. To find the area of the sector, again I'm going to use the formula for the area of a sector. Theta out of 360 times pi times r squared. My theta is 110 degrees divided by 360 degrees times pi times 3/4 squared. Notice that I put 3/4 in parentheses because I want to square both the 3 and the 4. Again, I'm going to do this problem without a calculator. 110 out of 360 simplifies down to 11 out of 36 times pi times, well, I can distribute to my numerator and to my denominator, and I'll get 9/16. 3/4 times 3/4 is 9/16. I'm going to put pi into a fraction, pi over 1. Now any time that I have a number in the numerator and the denominator that can be reduced, I'm going to do that. Like 9 and 36. 9 divided by 9 is 1. 36 divided by 9 is 4. Now in the numerator I have 11 times pi times 1, which is 11 pi. And in my denominator, 4 times 1 times 16, 4 times 16 is 64. So the area of my sector, the area of this wedge shape, is 11 pi divided by 64 inches squared. In our second example, we're given the area. So that's where I'm going to start. I'm going to start with the area formula. The area of a sector equals theta out of 360 degrees times pi times r squared. I'm going to plug in what I know. I know that my area has to be 175 out of 24. I know that theta in this case is going to be 105 degrees, and out of 360 degrees times pi times r squared. And I need to find the radius. Excuse me, I forgot my pi right here. I need to find the radius. So I need to solve this equation for r. Again, I'm going to try to do this without a calculator. First thing I want to do is divide 105 and 360. I know that 105 is divisible by 5. 105 divided by 5 is 21. And 360 divided by 5 is 72. Now 21 and 72 are both divisible by 3. 21 divided by 3 is 7. And 72 divided by 3 is 24. I forgot that pi again. Add it back in there. At this point, I need to undo the order of operations. To undo the order of operations, I want to get rid of this 7/24. Now I could divide both sides by 7/24, but there's an easier way. I'm going to multiply both sides by the reciprocal. When I multiply both sides by the reciprocal, my math becomes really easy. In fact, I can do this problem without a calculator. "24 cancels with 24. 175 and 7 both are divisible by 7. 7 divided by 7 is 1. 175 divided by 7 is 25. If you think of quarters, if you have 7 quarters, you have $1.75. So I'm left with 25 pi equals 24 and 24 will cancel, 7 and 7 will cancel, pi times r squared. I'm going to move this problem and finish it right here, give myself some more room. 25 pi equals pi times r squared. Now I want to get rid of this pi. To do that, I'm going to multiply both sides by the reciprocal. The reciprocal of pi is 1 over pi. So I'm going to multiply the left side by 1 over pi. To do that, I'm going to put 25 pi over 1, and I can cancel this pi in the numerator and this pi in the denominator, and I'm left with just 25. I'm going to put this pi over 1, and the pi in the numerator cancels with the pi in the denominator, and I'm left with just r squared. Keep solving for r by taking the square root of both sides, and I'm left with r equals 5. Now technically I have two answers here, -5 and +5, but my radius is never going to be -5. So I'm going to only worry about my +5 answer.